Okay, I'm redoing this video because the audio wasn't working properly. This gives you a good indication about how wide the sun is, and the way I did it, I guessed it was about 7 miles wide. And how I did it was, well, we know the angular diameter of the sun at any given time. I took the average. It's like from 0.524 to 0.542, about, so halfway between that. I chose 0.53. That's like a middle ground for that. So we take half of the Earth's circumference, which the full circumference is 24,901. So that's 12,450.5, because we see only about half of the sky. And then we take that 180 degrees and we divide it by 0.533 of a degree. And so we get 337.71 divisions within the 180 degree half circle. And so we take 12,450.5, which is the amount of miles in a half circle, divided by 337.71, which are the number of sections in 180 degree in a half circle. And so we get 36.887 miles at the ground. And so I just drew a little circle there to help you understand. That would be, if the sun was at the ground, it'd be 36.87 miles. So obviously it's a lot smaller, because within the concavity of the Earth, you see 3 circles there. You see the celestial sphere, the smallest one. Then the middle one is the glass sphere that surrounds the sun and the planets. And then the other one is the glass sphere that surrounds the moon. And so I have the sun located about right there. I have, it's roughly. I have to guess where it is. So it's about right there. It's a little bit closer toward the middle glass, because we have the so-called superior planets behind, and they're not going in front of. Only Venus and Mercury are. So it's about right there. Maybe it might even be a little bit closer to the glass. Let's move that over a little bit, like that over here. I think it's probably a little bit closer to the glass, because it's the thermal expansion caused when the heat of the sun goes in front of the glass. That's why we get that bulging like that. And so that's what they think is gravitational lensing. It's really just stellar displacement due to refraction through glass, and that bulge will follow the sun wherever it goes, and so it'll return to its normal state when the sun's not there. But anyway, I took that line from all the way to the left and I brought it closer in like that. So it's about that tall, 36.8. So let's roughly say 37 miles. And so I divided that line by 16. So 16 increments of that line is going to be 2.3 miles each increment. And so you see that distance at the bottom there. We have 1, 2, 3, just a little bit over 3. So we take a little bit over 3 times 2.3, and we get roughly 7. So the sun is 7 miles wide. A little bit different than what they tell you, huh? There you go, 7th heaven. The sun is 7 miles wide. You heard it here first.